This is my 3-year-old daughter, already choosing the dark side. I think I'm doing a good job there. No, but seriously, I've been doing cybersecurity for about 20 years, mostly doing consulting. I'm originally from Israel, but today I'm based in Paris. My most recent paying job, I was the head of cybersecurity for the OECD. In case you don't know the OECD, it's an international organization, much just like the UN, for example. And then a couple of years ago, I left that organization and I created Securitude, Security Cyber Solutions, and we have a very, very simple mission. We promote cyber innovations. So my clients are big corporations, and I help them identify, select, and implement innovative cybersecurity technologies, much just like deception that we're going to talk about today, but there are others. And I'm also a member of CYAN, the Cybersecurity Advisors Network, which is an international not-for-profit organization. We are a bunch of security experts and privacy experts and lawyers and accountants, and everybody's doing anything in cybersecurity, working together to create a better and safer online environment. And if you're interested in either of those things, please come find me after. But today we're going to talk about cyber deception. Before I do that, how many of you are working or have worked in an enterprise environment or a corporation environment? Great. So, I want to start talking today about the big old AV myth, the big old anti-malware myth. So, those of you who know and those of you who don't know, what do you think the 4 most popular, the biggest anti-malware engines in the corporate world today? Not the personal, but the corporate world.
McAfee, Semantic, Trend.
And you're so close.
No, not so close actually. It's
Microsoft, absolutely Microsoft. Windows Defender. So, absolutely, thank you. So Symantec, McAfee, Trend Micro, and Microsoft, together these 4 comprise about 80 to 90% of the corporate market. Now, because they are so big, there are independent labs out there that are testing these solutions to see how good they are. And I took the latest test that I could find, which was September 2018, by the AV Comparative something lab in this presentation. And the results are this. Amazing. Right? So 99% success rate, 99.8 success rate. Amazing results. And people, CISOs and security guys, security people, we're inclusive, they're taking this slide and these results to their bosses and saying, look, I got us McAfee, I got us Symantec, I got us the best in the market. And, there's an old saying, nobody was ever fired for buying IBM. So today, we're saying nobody was ever fired for buying McAfee, nobody was ever fired for buying Symantec or Trend Micro. The problem with this slide, the problem with these statistics in general, is that they are complete bullshit. And there's a reason why they are complete bullshit. They are complete bullshit because this is based on a lab environment. So these tests are being done in a lab environment in optimal conditions. There are 2 major differences between a lab environment and a real-world environment, and again, corporate environment. One is that they have all the features turned on. And if you ever worked in a corporate environment, you never, ever, ever turn all the features on because the number of false positives it creates is just too damn high. And also because it creates a lot of complaints from difference number 2, the users. And it's fine because security is and should always be second to people just doing their job. You can't have a security solution stop them from doing their job. So you never have all the features turned on. But specifically, I want to talk today about one feature specifically, and that is the online feature. It has many names depending on the vendor you're using. Some call it the cloud feature, some call it the connected feature. The point is this. When this specific anti-malware engine scans a binary or whatever it scans, it's not only using the local engine with the current, whatever it has, database it uses, but also in the cloud, where it has the latest engine, or even a bunch of engines. Excellent feature. Love that feature. Gives great results. Except, so yesterday, I came here from Paris. I live in Paris. I came from Paris to Bordeaux on the train. The train, when I bought the ticket, they said, you will have Wi-Fi in the train. That did not happen. So for 2.5 hours, I was offline, meaning my online feature did not work. As much as my, I'm in my own company, thank God, but if I was back working for the OECD, the people there, well, that was me, thinking that the online feature is turned on, but in reality it wasn't. And this happens a lot. And especially when you have BYOD solutions and you have other solutions, you can't control the environment. Now, 99%, 98%, how does this look like when you turn one feature off? It looks like this. One feature. Okay? And again, in real world, you turn off a lot more features. Actually, we've been doing tests and we've seen that the success rates of anti-malware solutions are at somewhere about the 40 to 50% success rate. Not exactly the best line of defense you can have. Now, the thing is, this is not new. I've been saying this, I've been using the same type of slides for the past 10 years or so. And every time I said that, or every time I said something new, the security people are telling me, yeah, it's fine. Everything is fine. And mostly they're saying it's fine because, okay, maybe you're right. But we have other stuff in place, right? We are doing defense in depth, which is, back when I did my CISSP, that was the #1 word. And they're using, so they're having the anti-malware and the network-based and host-based IDS and IPSs and sandboxes and SIM and all of that. But think about this. When WannaCry hit 2 years ago, when NotPetya hit a year and a half ago, for the Sony case, for the Target case, for every big thing we've been hearing about for the last couple of years, they all had this. This is useless. And they have one thing in common. The one thing in common they have is that they are all based on detection. Detection, this insane idea that we can ask a computer, a generic computer with software running on it, to look at binaries, to look at code in real time and decide if it's good or if it's bad. If it's good, carry on. If it's bad, no. 50%, okay? It doesn't work. It's an impossible task, and when you give somebody an impossible task, they are bound to fail. And so yeah, detection, I really pay detection. And the thing is this, when you're detecting something, when you're asking somebody to detect, the malware is already running, okay? It's probably too late at this point. It's been infected, it might have spread already to other systems, you just don't know. And, my clients, never mind. It's not about how advanced these solutions are. So it's not, so some people tell me, okay, maybe 5 years ago, 10 years ago, we had detection, but now we're doing something else. We have threat intelligence, and we have machine learning, and artificial intelligence, and all those nice buzzwords. But again, they are all doing the same thing. They are all trying to detect, and they are all pretty much too late. And it's too late because something called evasive techniques. Now, when I say evasive techniques, or when the industry says evasive techniques, it's just a nice way of saying that malware, advanced malware, and advanced attackers, have become the world's best player of hide and seek, right? Or as my daughter, because she was raised in France, so she calls it cache-cache. But my daughter is 3 years old, I remind you. And she's still at that age where she believes that if she can't see me, that must mean I can't see her. And that's amazing, and that's exactly what we're doing with detection solutions. Okay? We're telling ourselves, we are lying to ourselves, that if all of these detection solutions, the anti-malware and the sandbox and everything else, all of them told us that there is nothing suspicious going on. That must mean there is nothing suspicious going on. And we know that's not just not the case. And okay, so evasive techniques. What do I actually mean when I say evasive techniques? It means that they are using obfuscation. So we saw obfuscation today in Vishai's presentation. They are making themselves look like something else. There is a reason why a lot of the malware we saw in the last year are actually Python scripts wrapped as an executable, as a portable executable. The reason for that is that when you are doing static analysis, they all look like Python scripts packed as a portable executable. They look exactly the same. There's no way to differentiate between them. They're using a domain generation algorithm, completely rendered, so there's no way to predict it, even with artificial intelligence. And they're using tunneling to exfiltrate information. I've seen malware, so I've seen all of these examples. These are all real-world examples, exfiltrating information through DNS, through HTTP, through MySQL commands, which is one of my favorites, or BSSID, so wireless network names. So they're just creating wireless networks on the endpoint, and then somebody else is looking for those endpoints, and that's how they exfiltrate information over supposedly gapped networks. They're using military-grade encryption. Again, we said it before, they have access to much more funding and much more knowledge than the average security people in a corporation. They're using time delays. Again, a very favorite trick of malware. So when WannaCry came into a network, it did absolutely nothing for a week. Just nothing. Sandbox looks at it, saying nothing suspicious is going on here. Please go in. And that's exactly what happened. And most important, they are using environmental awareness, which means they know to look and they adapt their behavior according to the environment they're in. They behave differently in a sandbox than they would behave at an endpoint. They behave differently if they realize that there's specific security solutions on the endpoint, and if there's nothing. They are very, very smart. They became very, very smart. And at this point, when I say all of these to my clients, and they ask me, okay, thank you for scaring the hell out of us, but what now? Is there a solution? And the answer is absolutely yes. The answer is there is a solution. You can absolutely do things about this if you accept the notion that we have to stop doing security the same way we've been doing it for the past 40 years. We have to do something new. We have to think outside of the box. Or, boldly go, or I promised Star Trek references on Twitter. Explore new worlds, new civilizations. There are many, many technologies that came out, or I don't know if came out the right word, but that became good enough in the last couple of years. I'm not going to talk about all of them today, because I don't have the time. I do want to talk about deception technologies, which is what I came to do. So, deception. What is deception? Deception is the art of confusion. Detection solutions, classic detection solutions, are all about hunting. That's the key word. Right? They're looking around, trying to hunt attackers. Deception solutions are saying, no, I'm not going to do that. I'm going to confuse the attacker into making a mistake. I'm going to make them come to me. I'm going to make them show themselves. And there are, generally speaking, really, really generally speaking, there are two ways of doing that. One is we seduce the attacker. We give the attacker exactly what they want, exactly what they're looking for, so they come to us. And then, of course, we wait for them with a trap. Or we can do something else. We can confuse the attacker. We can give it so much information they don't know what is real and what is not real anymore. And that way we can sort of control their behavior, and obviously I will explain later. Now, when I say deception to my clients, and if my clients ever heard about deception, they probably heard about the first type of deception. Because they heard about something called honeypots. Now, honeypots. How many know honeypots? Ever heard about it? Excellent. Everybody. Honeypots is not new. We've been doing honeypots for, I don't know, 1970s, probably 1980s. But, for argument's sake, it means that we have our network. So let's call it just 1,000 machines in our network. And here and there, we put some fake machines with fake services. With the idea that if an attacker goes there, nobody's supposed to go there. So if somebody goes there, that must mean it's an attacker or somebody with malicious intent. There are two problems with the way we've been doing honeypots for the last 40 to 50 years. One, when I say honeypot, I basically mean a Linux machine with some fake services on it. Advanced malware. Remember, advanced malware have become very, very smart. They easily recognize this is a fake machine, this is a honeypot, and they stay way, way away from that. So it's kind of useless. Also, this was maybe fine when we had 5 servers in our network and we added 1 honeypot, great. But now that we have 1,000 servers in our network, 5,000 servers in our network, 4 honeypots are just not good enough. We need to bring the attacker to us. We need to make sure the attacker comes to us. Otherwise, we just have to miraculously wait. I don't know, maybe they do a port scan, or maybe somehow they find out these servers exist. We solve the first problem by saying no more fake machines. We are putting in the network real machines. Real machines. We're putting virtual machines with real operating systems and real services. So if and when an attacker comes, then they see an actual machine, and we can make it look like every other machine in the network. So it becomes very, very, very difficult for them to realize that they are actually in a honeypot. But the biggest problem is, of course, the second problem. And the second problem we solve by something called breadcrumbs, or lures, or traps, depending on the solution you choose. This is a marketing thing. So you have an endpoint in your network, and it's infected. And I want to be very, very clear here. It's not if you get an infected endpoint in the machine. You will get an infected endpoint in the machine because phishing, because whatever other type of way the attacker got in. But the point is, and we talked about the kill chain today, their goal is not, so this is the secretary's endpoint, right? This is somebody's endpoint. It's not the goal, it's not the target. The target is to go somewhere interesting, is to do lateral movement. So what they will do is they will look around inside the endpoint to see what other machines are there, or what credentials are there that they can use. And that's where we step in. We make sure to put there inside clues, little pieces of information, to make sure that the attacker will find them, and lead them to the right place. So if we have a honeypot, or a decoy, as we call them, that is, in effect, an internal web server, a PHP-based web server, then we will put cookies in Chrome, in Explorer, in Firefox, everywhere we can. So just to say, this machine has visited this internal web server. We can put Windows credentials in the credential manager, or Linux credentials in the password file. We can create net shares. We can create registry keys, SSH keys. We can basically put anything we want in the endpoint in a way that is completely transparent to the user. So the user, the regular user, should not look for them. By the way, if a regular user snoops around in your computers, in their own computer, finding interesting stuff and following them, this is something you want to know as a security practitioner. So it's not only about the external haha hacker thingy. So we make sure that the attacker finds these clues. We make sure that they will go to wherever we want them to go, and then we wait for them there. So either we let them go in, and then we continue the investigation, so that we can capture their binaries, we can, do a memory dump, a network dump, whatever it is we want in a controlled environment, or we shut it off, depending on what it is that we want to do. This is an amazing solution. It's an amazing type of solutions. I've been working with a bunch of them, and they were able to identify some 0 days, some very, very advanced attackers. The thing about honeypot solution or next generation honeypot solutions is that they are good for organizations that have the time, the resources, and the business case to do proper investigations. So if they have a SOC, or if they have a research team, like Salesforce, for example, they're big enough and they're interested enough for this kind of solution. But what about the rest of the world? What about, okay, not maybe large corporations, what about the medium corporations or smaller scale, large corporations? They don't want to do investigations. They don't care about investigations. They just want to stop the attack before it ever happens. And for that we have a couple of solutions, again, based on this session. Sorry. Before that, I completely forgot. Why sell for servers? I've been talking about honeypots, and I've been talking about fake servers and fake services and everything. But there is absolutely no reason that we should sell for servers. Why not creating just endpoints? So Windows, Linux, Mac, whatever. So we can create fake endpoints. We can create machines in the cloud, because half of our data center is in the cloud anyway. Why not put fake cloud instances? Why not create fake files that nobody is supposed to know about, nobody is supposed to open? So whenever somebody clicks on a file, we get an alert. We can create S3 buckets. We can create Docker containers. We can create devices on the network, so either a printer or an industrial device or whatever it is, we can fake. So this is of course a simulation. And we can basically put a lot of stuff on the network, and we have the technologies. Orchestration technology is pretty much available everywhere, so it's not something new. We can put them on the network, and we can simulate everything, just to make it more real for the attacker, just to make it more interesting for the attacker. Now, coming back to what I said before, if I don't want to do investigation, I just want to stop the attack, one thing I can do is simulation. Now, some advanced malware today are very, very targeted. So we've seen malware that is targeted towards ATMs, for example, or targeted towards smart TVs. Remember environmental awareness. They know what they are looking for. And if that's not what they're looking for, they will not attack, because their number one goal is to stay hidden. They don't want to create noise unnecessarily and then get caught. So we have technology today to hide stuff, to hide processes, to hide registry keys, to hide files, to make ATMs look like generic Windows XP machines, to make smart TVs look like generic Android phones. Malware comes there, looks for the artifacts that they are looking for, doesn't find them, and goes away. So one type of deception technologies we have is hiding. We're making ourselves look like something else. We're doing obfuscation, just like the malwares are doing. Or we can do the exact opposite. So once again, I remind you, malware comes and infects a machine. It will happen. And one of the things they will do is that they will look around. They will say, what kind of security solutions do you have? So for example, I put in a guard dog, very scary guard dog, and let's say that's an anti-malware solution, one of the 4 that we discussed before. We know now that malware is not scared of these type of solutions, so it will go anyway. One is not enough. We need more security solutions on our endpoints. So we do. We put IPS and IPSs, and we put personal firewalls, and we put all of that stuff. But even that is not enough. We need to think a bit differently. Now, we know from research that a lot of malware, so we saw today, actually in the example, that if a malware, for example, detects it's in a sandbox environment, it will do nothing. So what if we can make all of our endpoints actually look like a sandbox, actually be a virtual machine? What if we can, you know what, the number one thing that all malware is afraid of is debuggers, right? What if we can put a debugger on every endpoint in the network? Why not? Why not? Because it's expensive and because let's frankly, it's impossible. But we can do it with simulation. We have the technology today to simulate these artifacts, to make it look like we have those things installed. So we can put the debugger and we can put the sandbox artifact and we can put everything. And then we're thinking, if we can put those, why not put everything? Why not have a machine look like that it has McAfee, and it has Symantec, and it has TrendMicro, and it has 1,000 other antivirus or anti-malware engines. And at the same time, we can say it's a virtual machine and a physical machine, and it has a debugger, and it has everything. So we just simulate everything. And the malware looks at this, and the malware says, no. This is not okay, right? What if we can make every endpoint in the network look like a very badly executed honeypot? Okay? We know that malware go away when they see honeypots, so let's do that. Let's make them look like honeypot. And we have proven, we've seen that in 95% of the cases, or even more, when a malware sees something like this, it will decide to do nothing. We stop the attack without detecting it. We don't know what happened. We don't know who was there. We don't know what happened there. But we do know that we stopped the attack. And we also know that nobody's actually supposed to ask these questions from the operating system. So that's an alert. That's an alert that we just triggered. And we're telling the security people, go to this endpoint and do something about it. Yeah. So this is how the malware. And so we can take that same type of idea and we can extrapolate it. We can take it to the network level. So think of this again, 1,000 machines in our network, right? For a malware, for an advanced malware, it's not that big of a number. They can eventually go over each and every one of them and try to assess them. It might take them hours, it might take them days, it might take them weeks. By the way, do you know how much time? What's the average time of breach detection today in a corporate environment? How much time does it take between when an attacker gets into a network and until somebody notifies the CEO that something bad happened? On average.
Based on whose report?
Well, 216 based on 216.
8 months.
That sounds.
I have 206, which is close enough. So let's say over half a year. Okay, over 6 months.